accelerated algebra 2 stir here. This is worksheet 4D. Let's see if I can get through this without making too many errors. Ay. So the definition of the absolute value is basically, two piecewise functions. I guess it could be more than that. So you're doing each part, and we're dealing with a critical value. So let's see what we can do with that to improve our understanding of this stuff. All right, first thing we want to do is we want to evaluate. So we're just going to plug 0 in. We're going to plug 1 in. And we're going to plug -8 in. So 0 plus 5 is 5. Absolute value of 5 is 5. 5 minus 2 is equal to 3. 1 plus 5 is 6. Absolute value of 6 is 6. 6 minus 2 is 4. Absolute value of -8 plus 5 is -3. Absolute value of -3 is +3. So 3 minus 2 is 1. So what does the absolute value mean? The distance away from 0. Or distance from a critical point. Or critical line. Okay? All right, solve for x. Is there more than one solution? Yes, how do you know? So the first one we're going to come up with, and we're just going to have x is equal to 5, and we're also going to have x is equal to -5, because it's the same distance from our critical value. Our critical value on this one would be 0, because I don't have anything in there. Let's find my critical value on the second one. Critical value on this one, you go x minus 3 equals 0, so my critical value on this one is actually going to be 3. So we're talking about distance away from 3 that we're working with. So I'm going to go x minus 3 is equal to 5, and then I'm actually going to change the less simple side. I'm going to have x minus 3 equals -5. Okay, I'm not changing the absolute value, I'm changing the other side. So the first one, I'm going to get 8 as an answer. The second one, I'm going to get -2 as an answer. And 8 and -2 are the same distance away from 3. They're both the distance of 5 away from 3. So if you went 3 plus 5, you would get to 8. If you went 3 minus 5, you'd get to -2. So that's where the critical value starts helping you out with these problems. It says graph the following pair, identify the intersecting points. Okay, well, these might intersect. So we're going to take the first one, and I'm going to find a critical value. Looks like the critical value of this one would be 4. So at 4, 1, 2, 3, 4, somewhere on this line, we're going to have some turning point take place, okay? So let's go ahead and figure out what this is. I'm going to have -3 over 2x plus -3 times -4 is +12. +12 over 2 is 6. So we're going to go ahead and say at 6, 1, 2, 3, 4, 5, 6. And then we're going to go down 3, right 2, down 3, right 2. So I have that down 3, right 2. We already know what the other part of the graph is going to look like because we have this side taken care of. The other side of the graph is basically going to take place looking like this. I'm going to get 3 over 2x plus 6. Okay? So I'm going to go from this point here, open dot, down 3, right 2, down 3, right 2. So now I have these two for my absolute value, so that's taken care of. The other equation is, what does this look like when we graph it? Well, it's a horizontal line at -6. So I'm going to go down to 1, 2, 3, 4, 5, 6. Okay? I have this horizontal line. And on our graph, it appears that we have an intersection here and an intersection there. So I would say, let's see if that's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So that's at 8, 6 is an intersecting point. And this other one is at 0, 6. Oh, those should have both been -6s. First error. Oh boy. So let's consider a couple curveball scenarios. Okay, the absolute value of x, so my critical value on this one is equal to 0. So it's right along here. So at 0, I'm going to go up one, right one. And then this one, I'm going to go left one, up one. Okay, so that's what our absolute value graph basically looks like. I basically graphed x, and I graphed negative x. And I had x is greater than 0 or equal to 0, and x is less than 0 as my two parts of my thing. But then if we graph this portion, that is a horizontal line down here, so it looks like this. Okay, friends, talk to me. Will these two graphs intersect each other? And the answer is no. So this particular one has no solution. Our two graphs will not intersect each other. Let's think about this second problem. Maybe the same idea, I don't know. So this one would have a critical value at 0. The same critical value. 5. Let me go down one, right one. So this is what this graph looks like. And then down one, left one. This is what it looks like over here. Open dot, close dot. Of course, if we were graphing this, we have negative x plus 5. And we also have x plus 5 is our other equation. So the top one has a domain from 0 to infinity. Bottom one has a domain, I guess I could make a square bracket on 0, negative infinity to 0, rounded bracket. And then we have this 8. Well, that 8 takes place up here. So 1, 2, 3, 4, 5, 6, 7, 8. Again, we have this horizontal line. Will these graphs ever intersect? No. So we have no solution to this problem. They don't have any points in common that they would share. All right, solve the absolute value using the number line process along with mental math. Okay, so now we want to let's get away from the x and y axis. Well, let's just talk about the x-axis because I don't have y up here. So my critical value to this problem is negative 3. So I'm just going to put negative 3 on this graph. Okay? And then when we go work through this problem a little bit, let's think about what things would look like. On the left side, we have positive. On the right side, we have positive. On the left side, we have negative. On the right side, negative, positive, negative, negative, positive. So let's go ahead and solve this. So I have x plus 3 equals 9. So x equals 6. And then x plus 3 equals negative 9. So x equals negative 12. So I have negative 12 down here, and I have 6 over here. So the nice thing is the distance here is the same. That distance there is the same as this distance here. That critical value is important for us when we're working this problem. Okay, so our two answers to this basic problem are negative 12 and 6. Negative 12 and 6 are the 2 points that are the same distance away from negative 3. Let's do the same idea over here. So we're going to create ourselves a number line. Looks like our critical value is equal to 0. CB. Okay? And let's go ahead and solve it. So I get negative 2x is equal to 8. So x equals negative 4. So let's plot negative 4 down here. And then on the other side, we're going to go negative 2x equals negative 8. So x is equal to positive 4. Positive 4 is right here. So negative 4 and positive 4 are the same distance away from 0. 0 happens to be our critical value. So our answers to this problem are here and here. Well, that's our critical value. Now let's go a little bit. The absolute value is the number line process still, but we have a few more things that we're adding to this problem. So let's do this. Critical value, what do you think? Yeah, it's 4. Okay, just solve whatever inside the absolute values that are equal to 0. And let's go ahead and solve this problem. So I have 2x minus 8, I distributed over, plus 1 equals 7. So 2x minus 7 equals 7. 2x is equal to 14. So x is equal to 7. So there's one value. And then the other one, we're going to do the same thing. We're going to go 2x minus 8 plus 1 is equal to negative 7. So change that side. So I get 2x minus 7 equals negative 7. add 7 to both sides, so I get to 0, so x is equal to 0. Wow. Done. Pretty cool. There's our other value. So if I get 1, 2, 3, 4, 5, 6, 7, so you have the same distance between these points. That's our critical value. These are my answers. Okay, again, we're going to take a look at the number line process. So our critical value is a little tougher to get on this one, isn't it? So I have negative 1/3 x minus 3 equals 0. So 1/3 x equals 3 by adding 3 to both sides. Multiply both sides by 3, so x equals 9. So that's my critical value. Let's create a number line. So we have 9 here. That's my critical value. And let's solve for the rest of the problem. So I have negative 1/3 x minus 3 plus 8 equals 15. Let's go ahead and solve that. 1/3 x plus 5 equals 15. We're going to subtract 5 from both sides. 10, so x is equal to 30. So 30 is way over here. Now let's go ahead and solve the other side. So I get 1/3 x minus 3 plus 8 is equal to negative 15. 1/3 x plus 5 is equal to negative 15. Subtract the 5 from both sides, or add 5 to both sides, so we're going to get to subtract it, so it's a negative 20. Then we get x is equal to negative 60. What did we do wrong with this problem? Let's take a look. So I agree with the critical value. Let's see. Does anyone see my error? Let's talk about this one in class. This one will be a class discussion, so bring this one to class and let's take a look at it. I might have made errors. Some of you might have actually found where I made the error on the problem. So that's it. Take care of yourselves, take care of one another, and bring that last question to class and we'll double check it. I made an error someplace.